Hello. Welcome to Dr. Drumo's
Wait!
office. Hello. Welcome to Dr. Drumo's office.
Our overall goal for helping our friend is to use experimental methods to discover the different ways that elephant toothpaste can be affected. This will be tested by using height, reaction time,
And how pretty it gets.
The overall result of the experiment will vary depending on what catalyst we use, potassium iodide or yeast, and what percent hydrogen peroxide we use.
In order to make this toothpaste, we must use extremely precise measurements of these materials. Exactly one wrong move and we will blow the paste up.
Not exactly for our first experiment, Miss Cat.
That's right. For our first experiment, we are going to use a kid-friendly version.
A much weaker substitutional method.
Exactly my point.
Let us first talk about what a catalyst is.
A catalyst speeds up the overall time it takes for a chemical reaction to occur without tempering its products.
For our first example/experiment, we will be using yeast, which contains an enzyme called catalase. Ha ha ha! Get it, cat? Cat? A lace?
No.
Anyways, those will speed up the overall process of breaking down the 2H2O2.
This will break down the individual molecules of water and 2H2O2 and result with the oxygen getting trapped by the dishwashing liquid. Remember, this is only 3% 2H2O2 and yeast. It will only provide a small physical reaction.
Okay. However, this toothpaste is kid-friendly, so it's using household products and is safe to touch. Here is the simple formula for the reaction we are about to witness.
It is 2H2O2 yields 2H2O plus O2.
We notice that this is a decomposition reaction, Mr. Blessington, when a chemical that is made up of only one molecule breaks down to two different smaller molecules.
Now, when you do this type of experiment, you must remember that you cannot use cold water because you will get no reaction.
No reaction.
Or you can't use hot water because it will kill the yeast.
Kill the yeast.
Now, this type of reaction is an exothermic reaction, meaning that it gives off heat.
Heat. So let's go!
Okay,
So now that I'm back in my office.
our office.
Right. Our office. It's time to begin the experiment by cleaning the table of any important things.
Okay, so now that we are ready, the ingredients for this reaction are 1/4 a cup of dishwashing liquid, 1/2 of a cup of hydrogen peroxide, and instant yeast. Now, what color shall we use? Good.
Yeah.
Okay, we will first start with a good glass cup. Do not
This
drink.
smells like bread. That's because yeast makes up bread.
We take hydrogen peroxide. We take dishwashing liquid. It appears I need help. Good, good.
Food coloring. And then we pour the yeast. Thumbnail. 3,
2,
1, go! Wow! was really intense.
It is seeping through table.
Now remember, this is kid friendly, so let's have some fun.
Jess,
Woo!
if you were to touch it, you can see that it is extremely warm.
Though this was a dandy old time, I think it is time to have maybe a bigger experiment. How about that?
It might work better. No, I think we
For
need
our
to
elephants.
use, instead of yeast, we will use potassium iodide.
We
We'll
use
30%
30% hydrogen peroxide. So, now that we have cleaned my office, it's
Our office!
That's what I said. Now that we're back and have cleaned our office, it is time to look at a more in-depth and very strong experiment by using potassium iodide instead of yeast and 30% hydrogen peroxide instead of 3%.
But wait, what does the concentration of hydrogen peroxide have to do with anything?
Well, you see, the concentration of 2H2O2 is extremely important, for it says how strong and concentrated it is. Well, 6% is twice as concentrated as 3% hydrogen peroxide. And on top of that, if you used 30% hydrogen peroxide on a cut, you'd be in a bit of a doozy.
Not only could you damage a person, but it could damage the things. 2H2O2 is used commonly to remove stains that are typically hard to get out of fabric.
And while you can't easily strengthen the concentration of 2H2O2, you can easily weaken it by adding water.
This also can relate to the physicality of the product. For example, a weaker concentration of hydrogen peroxide contains more water, making it heavier, while a stronger concentration contains less water, making it high.
Okay, enough about hydrogen peroxide. Can we go mix something?
Not yet! We need to talk about the chemicals being used in substitution of yeast, such as sodium iodide, potassium iodide, or iron 3 chloride.
Right.
So, the difference between the sodium iodide and yeast is a bigger and more drastic reaction. However, today we will be using potassium iodide, but has the same differences. The yeast interacting with hydrogen peroxide is much simpler. So, the potassium iodide reacts with the hydrogen peroxide by removing an oxygen atom. It produces the foam. This then produces oxygen gas, water, and iodine.
Well, if iodine stains, then that means if you touch it, will your hand be stained yellow?
That is exactly right.
Oh my goodness. All right, well, let's go do some experimenting.
Hello, it is Dr. Catherine. It is evident that Dr. Petty is not in the room right now, so I will be continuing this experiment by myself. As we said before, we would be doing the experiment with 30% hydrogen peroxide. So, this is 30% hydrogen peroxide, 50 milliliters. Here we have 29.5 milliliters of dishwashing liquid. I will now put in potassium iodide.